Hello and welcome to the Fully Charged Show podcast. This week's episode, very interesting. I think a lot of you are going to love what you hear today. This is quite extraordinary. So, as I mentioned in the beginning of this conversation with this week's guest, I had seen induction or wireless charging many years ago. A lot of different companies were launching and experimenting with and developing induction charging technology. It then went kind of quiet. We did see the induction charging road in Paris that Renault were involved with, where you could drive across the top of a long row of induction charging plates at like 50 miles an hour and be charging at 32 kilowatts or even more than that. It was amazing. I'm talking this week to a wonderful man called Mike McHale, who is head of communications at a company called Momentum Dynamics, who are based in Malvern, Pennsylvania. Not Malvern, Worcestershire, no. The New Malvern in Pennsylvania, and they build high-speed wireless charging systems. Michael McHale has, he's been knocking around the automotive industry for a while. He's worked for a couple of car companies you might have heard of: Land Rover, BMW, Subaru, Rivian. Yes, he was at Rivian until very recently, and clearly there is a connection between the technology, as you will hear, the technology that Momentum Dynamics are producing and Rivian, who are in the process of manufacturing 100,000 electric delivery vans for Amazon in the United States. So this is a really fascinating conversation about how this technology has developed and where it's going to go, and hopefully at some time in the near future we will be able to see this technology in working. But I will let Michael explain where they're first putting in a seriously proper amount of induction charging plates, in this case to help taxi drivers. So Michael, thank you so much for finding time to talk to me, because this is really exciting for me, because I'm not a proper journalist, as I'm sure you're aware, anything but this is sort of almost a scoop. But it's very exciting news. But it's also fascinating because it's dealing with one of the technologies that I was made aware of many years ago. I remember a Volkswagen demonstration using induction charging. I saw examples of induction charging 8-9 years ago, and then you kind of hear nothing. So can you explain what Momentum Dynamics does and what your involvement in this project is? Because I know it's not just you.
That's right. So Momentum Dynamics is a wireless charging company. We're based in Philadelphia on the east coast of the States. And we develop a wireless charging system for vehicles. And you're quite right to say wireless charging has been around for a while. It's the same thing that charges your phone when you put it on the pad there at much, much lower levels. And there are the system is based on a principle shown by Nikola Tesla, back in the long distant past, of electricity traveling through the air and magnetic fields and so on. So the principle is well understood. A couple of systems have come to market that are lower power, so they get in the 11 kilowatt range or 22 kilowatt range, mainly 11. So in principle they look good, but of course with a 150 kilowatt hour battery, that's a long time. So it's difficult to charge up at those rates. So in principle good, in practice not so good. Our system runs at 50 kilowatts and above. We start at 75 kilowatts in that kind of range, and we can run up to 300 or 450 kilowatts with modular pads. They all sit next to each other like a little Lego brick. You drive your car over the top of them. They sense each other and say hello, and then start charging, or they create a magnetic field which excites the car's system, and then to the car, we look like a DC fast charger. The car doesn't know. It's magic that happens outside of the car, and the car gets charged. But the benefit of our system, if you have questions, I'll stop now, but there's a real benefit to our system that you don't get with other plug-in systems. Any questions, or should I carry on?
No, I mean, well, I've got millions of questions, but I want you to carry on, because I'm sort of, you carry on, because then if I think of something, I'll get excited and ask a question.
We all want the world to go electric. We know that. I was at Rivian before I do this thing, and I'm fully committed to the cause. I think it's a wonderful proposition. But there is nothing in the world that's perfect that I have found. And plug-in systems are terrific. They are great, and they will help a lot of people move to electric. It's a terrific thing. But there is a downside to a plug-in system in that you actually have to physically plug it in. So if you're going home at night and plugging it in and wake up in the morning, that's not so bad, unless your arms are full of groceries or something. And that's fine. But if you're trying to produce a system that creates partial charging, so that every time you hit point A on your route, you just get 5 minutes of charging, that's a beautiful thing. Now, if you're a taxi driver, for example, and you don't want to, I was talking to some cab drivers in London, like, I don't want to go off route, mate. Every time I have to go off route, I've got to charge this thing up. It takes me 4 hours, right? Bloody pain in the arse, right? So all that happens. And we said, well, how about that when you're in the taxi rank and you're in line to pick up your next customer, you're receiving 6 minutes of charge or 8 minutes of charge. You don't have to get out. You stay in line and you receive this charge, and then on your way, you do 20 miles and you come back and do it again. So that same principle applies to buses and last mile delivery, and all of the fleet carriers you can think about would like that too. So we talked to the city of Oslo, and it's a consortium between us, Fortum, Jaguar Land Rover, and the city of Oslo, to create a system where their taxi drivers can use electric vehicles, because the hindrance for them was just that. They would start off in the morning, they'd be fully charged, they'd start to lose charge by lunch, and they've got to go off for an hour and charge up by the time you're out of the rank and you've found an open system and all these things. And so we can keep them running. And then, of course, in the longer run, there's an even better benefit. But I'll get to that in a second.
Well, I mean, the difference then is, because you kind of pointed that out earlier on, but I just want to sort of underline that for our listeners. But the early induction charging units that I saw, I think one of them was running on a BMW i3 and another one was on a Golf, and they were both in the sort of 7 to 11 kilowatts. So it was kind of, it was still a brilliant thing, if when you went to a multi-story car park and you park your car in a space and it's got that much power and you do nothing, you just drive it, park it, get out, walk away, it's charging, brilliant. But it isn't charging that fast. But what you're talking about is the potential for something like an iPace to be in a queue for 5 minutes, but it would add 30, 40, maybe 50 miles range in that time. I mean,
that's exactly right. And then if you take that out to its longer term future, we see a future where you don't need to see cables. Now, you live in a high residential area. You don't want to see cables in your street, or in your, Kensington High Street is not the place for cables. And we would quite like to provide the world with a system where all of the charging is invisible. So you can drive into Wimbledon. We'd love to put one outside of number 10. That's my great dream. But, Boris drives up and gets out of the car, and the car is charging and nobody knows. And that's our dream. So we think we can reduce this clutter that's going to come with cables.
Yes. In cities, it really is. Something. In fact, I mean, it is the kind of solution that everyone is looking for at the moment. So, I know the statistics are boring. I've mentioned them many times, but it is 40% of UK households don't have anywhere to park a car off the road, which I think is actually lower than I would have expected. I would have thought it was more than that. But so 60% can, 40% can't. But that 40%, there's a lot of people I know who would love to have an electric car, and they go, well, I can't, I've got to plug it in at the weekend or do something. How do I do it? And the idea that they just park on their street somewhere and the car is charging is the sort of dream of that. But I mean, just explain a few things. Is this the charging pads you're talking about? Are they able to be set into the road or underneath the ground a little bit, or how does that?
Yeah, that's right. And in fact, that's how we do it. We bury them into the ground, so they're below surface, and that's two advantages. A is you cannot graffiti something that's below the surface. Try as you might. So we like that. And secondly, really, it's about creating a robust system. So you're not going to knock it down. You're not going to run over it. You're not going to drive over the cable. It's completely buried. and the pad sits on the vehicle, either front or back of the vehicle. For delivery vans, those that back into a loading bay, we can put the pad on the back of the bay, on the back of the truck, and then they can be charging while they're loading their vehicle. So yes, it's buried into the ground. We can put it on a surface in a garage situation. So if you're indoors and it's your facility and it's not going to snow, you can put it on the surface. But on a roadway, with road sweepers and snow removal, you want it buried, and that's the way we do it.
I mean, I remember when I went to the very first kind of press launch of an induction charger, where they had one demonstrating. What was amazing was the general press. They immediately came up with sort of 500 scenarios that were lethal. A ball rolls under the car and a child puts his arm under and it melts his arm, or cooks his arm, or whatever, or a kitten. It's usually a kitten or a child. But presumably, I mean, I completely accept that one of the fairly early steps in developing this technology was to make sure it didn't cook children.
It's in the user manual. So the question's always there, because I think we always like to play sleuth, don't we? Like, but what if? We all, and it's good, it's fine. So there are a couple of things to understand about the system. It's a magnetic field. It's not meant to radiate out past the pad, because that's like having your hose pipe on and just letting all the water splash everywhere. We don't want that. We want the energy moving from the pad to the vehicle. And it's a very small magnetic field, and it extends just really to the size of the pad. It's extremely efficient in that way. And it also has, foreign object detection. So if there's something under the vehicle, it will alert. And it's only working, of course, when there's a vehicle there, because we're not throwing out energy into the atmosphere for fun. We only want it to work when there's something to receive it. So the pad only becomes alive when a vehicle engages with it and says, I'm there, let's talk.
So if you stand above where the pad is, normally there is nothing going on.
That's right. And the other thing to think about too, our system operates at 85 kilohertz. It's a really low resonance system. If you compare that to the 2.4 gigahertz in your modem that's behind you there, then it's a factors of magnitude different. So it's very much like an inductive cooktop. It works the same way as that, and generally we believe that in normal use, if you're a pedestrian getting on that bus or in that taxi, you're seeing less effect from that pad than you would be from the RFID things that are in Fortnum and Mason, that are protecting the clothes in there. It's that magnitude of effect.
The other question I remember regarding this is, that you would assume that a wire joining, socket A to car B, I would have assumed no losses, but there are some losses. But then I would immediately assume that something like an induction pad, there'd be huge losses. You're going to have to pump all this power in, and some of it leaks out and goes to the pad on the car, and you get like 2% of the electricity you're putting into the ground. But that's not quite true, is it?
We get that question a lot too, when you look at the high-speed chargers, the DC chargers, the big guys, and the liquid cooling that's happening there, they're cooling not for fun. It's because there's heat, and heat is because of resistance, and resistance is their inefficiency. And when you see these long cable solutions, the robotic arms and so on, that are 20 feet long, that's a lot of cable to push electricity through. And copper's, a very conductive material, but it has losses like everything else. Now, the air gap we're talking about is 6 to 7 inches. And so it's your hand's width between those two pads. And we see efficiencies, the 92 to 94% range. We're right up there with everybody else because we don't have all those cables. And the other efficiency, and this is a little too deep maybe for this conversation, but if we have a bus that has 150 mile range and so many kilometers range, and we can charge it en route, it never needs to come back to the depot. So right now they go out to all the best will in the world, and it's a cold day and they're done by lunchtime, and they have to replace them with another bus. We just keep that same bus moving. So in terms of operational efficiency, system efficiency, we can save you the cost of a bus. and they're very expensive. So if you're in the City of London and you're riding around on an electric bus, they have lots of zeros behind them. They're very expensive. And you either buy 10 with a plug-in system, or with us you buy 8. And we keep all 8 moving all day, and you don't need the backups. So that's the other side of our commercial opportunity.
So then when you're talking about that, then are you saying, because obviously, buses stop constantly, that's the very nature of a bus, so that are they only charging at the bus stop? Is that the point where you're...
That's right. We take a route, and it might be a 10-mile route, and then if it's a 10-mile route, there may be one pad on that route, and then every time it hits there, it charges for 8 minutes as it's picking people up, then goes back again. If it's a 20-mile route, there might be 2 pads. And we can vary it, and the system's really clever. It will talk to the bus and say, how are you feeling today? And the bus will say, I'd like a bit more, please. Like, all right. So we give them a bit more. It's a cold day or it's a warm day. They don't need as much. And so it's a very intelligent system.
Now, I've seen buses that have like cantilever charge points on the roof, which, look a little bit cumbersome, but, clearly an expensive installation, an expensive piece of equipment that is exposed to the elements.
So what we say about those systems, when we see those systems, we say that it proves there's a need. But not necessarily that is the solution, but it's showing us that there's a need for these things. And if you compare a 20-foot robotic arm and couplers and swinging robots and all of this with a 24-inch square, 2/3 of a meter square pad that's buried in the ground you never touch, we clearly have the advantage. But what we do like about the robotic systems is that it proves that need. We just think there are better ways to answer it.
And I mean, is there anything because I'm just wondering what steps, what advances there have been in the kind of technology you're using since I would have seen an induction charging pad in, 2012, 2013.
But without getting too technical on it, the systems that you're familiar with, they started small and tried to grow the system. And in their systems, that means they become inherently lossy as they try to grow. We started our system at the 50, 75 kilowatt range. We started our systems to be bigger, and because it's easier to scale them down into something that will fit a car one day. And we can do the smaller stuff too, but with right now the 50, 75 kilowatt and above is the sweet spot for our commercial needs. If you're a delivery company that one day sees your deliveries not having a driver, then the only way to charge that vehicle is wirelessly.
Yes, of course. Yeah, because you haven't got a driver to get out and plug it in.
Your little pod drives from your garage, your depot area, out to the sticks, delivers its bits, drives back and docks itself for charging, and off it goes again. So, that's why we're building at that size, because of those needs. The reason why we have become so much more efficient is really clever and techy, and I would rather the engineers explain that to you. But our pads match, they're match size pads, so the pad on the vehicle is the same size as the one on the ground. And they have a very clever resonant magnetic technology that means they're highly attuned to talking to only each other. And that sort of is really how it works. But cleverer people than I can tell you that.
I suppose the two drawbacks I can see, because I'm doing a bit of what ifing. But it is the expense of installing it in the road, and then also I'm intrigued by the expense of adding it to a vehicle. I mean, obviously in a perfect world it would be built into the vehicle, and it obviously could be very easily. That kind of electronics would be an easy addition to the construction, but at the moment you're going to have to add them to the vehicles, I assume.
Digging a hole in the road is not quite as hard as you think it is. Apparently, takes 3 days, and most of that is allowing the concrete to reset again. So you dig the hole in the road, you connect it all in, and it's buried there with an access hole, so you can fix it if it goes wrong. It doesn't do because there's no moving parts. So the installation is not difficult. Of course, we have to connect to the grid, and we need a cabinet that connects that and makes that happen. But that can happen away from the beauty spot on Kensington High Street. The second part is on the vehicle. Now, on the bus side of things, what we really stressed to the bus people is that stop building bigger buses with bigger batteries, because you're just carrying that battery around all day long for no good reason. You remember probably the horsepower wars of the early 2000s, where BMW had a 500 horsepower against AMG, it was a 550 and all of that stuff. So we're into the range wars now, and you can see this bigger and bigger battery thing. Stop building big batteries and lunking that thing around all day. That does not make sense. We would rather save the space and weight on the vehicle, reduce your battery size by 2/3, go and put them in another bus, and we'll take up a little bit of space and put a pad on. So our pads right now are currently, 2 feet by 2 feet. I live in America, so I'm all imperial. Just over half a meter square. And for a bus, we can put 6 on. For a car, we put 1 on.
I see. Oh, God. Okay, that's a good piece of information. Yeah.
So like Lego bricks, we put as many pads on as we need. And that's what keeps the system efficient too. Instead of one big pad that gets a bit lossy, we have 6 of them. And also they're in series, so each one of them is talking to, in parallel. So each one of them is talking to the vehicle. So if one does go down, you've still got 5. It's okay. All of that happens. So in the car field, it's that same conversation. It's talking to the OEMs and saying, stop building bigger and bigger batteries. And that's a lot of weight and a lot of cost still, even though battery costs are falling. We all know that. Stop doing that, because you're compromising your vehicle design. It's so big. It's why some companies are coming out with big SUVs first. That's why they do it. We can save you all of that, and we can put a small thing underneath that will extend your vehicle all day long. And then it does become a convenience feature too. So then it does mean if it's in your driveway, you've got a handful of shopping, your kids are barking, your dog's crying, all that, there's no plugging in, and there's no yelling at your partner because they didn't plug in last night. It just happens.
And is that, because one of the things I remember being delighted by was when I drove this BMW i3, I could see the pad in front of me, but once you drive over it, you couldn't see it. But there was very clear software that sort of went bing, 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 ding, when you were in the right place. And I really enjoy, simple things. I really enjoyed that. But it made it very clear, this isn't hard to do. You just drive it forward until it bings. But is that a similar thing? A bus stop, you can kind of imagine the bus stops in the same place every time anyway, and the driver would know how to do that.
The bus drivers are actually really skilled. When we talk to them about it, they take pride in their ability to position a bus for a wheelchair access, because they have to. That's the law, and it's part of their little gig every day. They enjoy it. But I park with less precision than that. My wife will tell you. But yeah, you get the little indicator, and we have various ways we can do that, depending on the situation, and you will know. And of course, if you can imagine 4 pads in a square in a grid, like the little Windows symbol, and there's 4 in the grid, and if the car you're using only needs 1 of those pads, you'll align over that 1 pad, and there'll be a different alignment for you, and the other 3 won't come on. It's that kind of cleverness.
So what you're doing then, the first time this is going to be running on a sort of normal inner city commercial level is in Oslo and they're Jaguar I-Paces that they're using as the taxis, is that right?
Jaguar have a really strong interest in electrification. That's part of their, I think it's Global Zero. I'm sorry if I get that wrong, JLR. But it's that, they're committed to the future and all of that. And this is a great way for them to show it. You'd have to ask them more details, but that's the partnership. We're with them, a utility company in Norway, in the city's behind it, which is really nice. And so the cab drivers of Oslo get to drive electric vehicles and don't have to charge them up. It's a really nice thing.
And that's so that you'll be putting them in like the cab ranks at the station or the airport or...
Yeah, the future looks like that. So if you're a cab driver in London, in the medium-term future, the almost immediate future, you drive from City Airport to Fortnum and Mason to Oxford Street and back to City Airport, and you do that, all day long, and then you go home. I was interested to talk to some of the cab drivers when we were doing our research, and a lot of these guys drive in from outside London, and they're saying, my electric range is done by the time I get in. And I just don't tell anyone. I'm like, oh, okay. I said, well, how would you like it if you could just charge up while you're standing outside King's Cross? Like, love it.
The sort of positive side of the new electric cabs that are in London is that I love the sort of change of tone of the drivers, because I always say, how are you finding this? And it's universally charging is the problem. They love the cars. I haven't met one yet that doesn't like the car. They go, it's brilliant. I love it. It's so much more comfortable, so much easier to drive. My passengers love it, everything, and all that. And I go, what about charging? And there's usually a little silence and then some swearing, quite often aimed at Mayor Khan. Seems to be the butt of a lot of it. But, it's really interesting. That's the side that they want resolved. I've met one who said, I don't know why they all moan about it. It's easy. I just stop for my lunch and use a rapid charger up round the back.
I mean, Roger Atkins well. Roger and I stood outside King's Cross for 2 hours. This is the kind of work we do now. So much fun. And we literally stood there watching the cab behaviour. And every single one we asked, why don't you drive electric? Yeah, charging, mate. Bloody charging. And so once we said, well, how about if it was charging now while we're talking to you? Absolutely, mate. And so it's there. The demand is there. We've just got to move this whole thing through.
But you can really see, I mean, as you're rightly saying, I mean, in a way, this is more, the really serious advantage of this stuff is for commercial traffic. It's for delivery vans, buses, taxis. You can just see that really being adopted quickly. And also it would be adopted by companies that can see the big picture in terms of running costs and fuel costs and all those things.
One of the things that we're seeing now, which is really interesting, if you take a pilot of 2 buses or 2 trucks or whatever your business is, and you plug them in every night and you think, this isn't too bad, we can do this. So you end up down the wrong alley, because suddenly your 2 buses becomes 20 and 20 becomes 200. The bus depots in this country, in the States, are 200 buses. Now, if you're trying to plug those in every night and each one takes you 5 minutes, that's 1,000 minutes. So that's a lot of time for somebody just to walk around.
But it's also having the infrastructure to support that.
So now you've got 1,000 cables and 1,000 plugs, and they all wear out, and so on and so on. And I don't mean to denigrate plug-in. It's going to get us moving. It's the right thing to do. Anything that gets electric cars on the road is good by me. But the more efficient way to charge 200 vehicles in a station is just drive them over a pad and walk away.
It makes so much sense. No, that does. Because the one thing I've seen more recently, which is in Paris, which I'm sure you've heard of, is that there is a strip of road. It's actually on a military base. It's not a public road, but a strip of road where they put in a kind of row of probably 500 metres of induction chargers, and then they drove a Renault Kangoo van over it. And we could see it was receiving a 55 kilowatt charge at 60 kilometres an hour. So as it drove past us, it was charging. And so you go, it's amazing technology, but you then thought to dig up every freeway in the world and put that in it's quite a big cost.
We don't recommend it. It's just not worth it yet. If you really want it, we can do it for you. But it's, if you do, but it's right now the best way to do it is in the natural stopping of vehicles, and we know where that happens, and we watch them. We've done the studies, and we can see the last mile delivery people. It's at loading. It's a mad scramble. If you've ever been to one of those places, they're fascinating. You watch these trucks back in, and it's go, 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 and then they're out delivering. But while they're loading, we're quietly charging them, and that's the future for us.
The only other thing I really want to ask you about, and I don't know how much you can talk about it, but the fact that you worked at Rivian, and everyone I know who's ever had any interest in electric vehicles starts dribbling. Literally starts dribbling, if not dribbling, quivering when there's a mention of Rivian. And I saw the cars early this year at the show in Texas, and they are very impressive.
That's the last time we met, was the planning for that show. I came and did the little pre-thing with you in Austin. I have nothing but good things to say about them. They're an incredible brand. They will absolutely succeed in the marketplace. It's a clear vision.
I mean, that's one thing I wanted to ask, because I've certainly seen so many phenomenally potential, wonderful startup electric car companies all over the world. And I have to say, at the moment, Rivian is the only one that I'm more confident will be here in 10 years' time making lots of cars.
Yeah, I have never seen a company with clarity of purpose the way they have it. And that comes from RJ. RJ absolutely knows what their company's going to be. And it will succeed. And that's to the betterment of everyone. And, you see now all of these other trucks coming along and all of these other competitors. That's fine. Again, it goes back to what I was saying earlier. It proves the market. If you're the only people doing something, you might not be in the right market. You want to see a bit of competition, and Rivian will have some stiff competition. That's just good for everybody. It means that you will be driving a better truck in a couple of years' time.
I mean, I'm just sort of thinking of Synergies in your future. But, one of the news of Rivian, the company making, 100,000 electric delivery vans for Amazon. That is a perfect example of a vehicle that needs induction charging.
I thank you for recognizing that. Let's say, we're talking to pretty much everybody about this, because it's a bit like Andy, my boss at Momentum. It's his company. He started this 10 years ago. He's ex-International Space Station. And it's sort of interesting. I said to him, I'm the PR guy and I'm trying to dig into his story. How did you get into this? He's like, I hate cables. On a space station, they weigh a ton. Yeah, okay, so why can't we just transfer the data wirelessly? And if we can transfer data, why can't we transfer power? And that's how he got into it. He's been doing this for 10 years, and I think this is a bit like the 10-year cicadas we get in this country. And their life cycle, they sit dormant for 10 years, nothing happens, and then one day they all go into the tree, and they make a hell of a noise, and then they bloom, but all the conditions have to be right. And that's what's happening now. So it's a really cool time to be in this space, because we're talking to last minute delivery people and taxi people and fleet people and big drayage companies and all of that stuff. And they're saying, oh yeah, now this makes sense. And Andy's there saying, finally, 10 years I've been trying. But now he's got his product to the point. He's refined his product over the last really 8 years to the point where it's absolutely the right thing to do. It bolts onto the vehicle. It works easily. We integrated with JLR on their project in, I think it was 2 to 3 weeks. We took the pad over, we plugged it in. It's a plug-in. You make sure that the plugs are the right type of plugs. You plug them in. The BMS talks to the thing and says hello, and then you're good to go.
So you're not having to sort of saw holes in the vehicle or rewire it all together. You can work it. And I think the thing with that is hardware in electric vehicles. Hardware is always quite easy. The software is the real bugbear. And if you're managing to operate within the software's parameters, then that's a massive advantage.
Telling me there's something like 4 questions that the BMS really asks. And it's the same ones we all ask when we're children. It's like, I'm hungry, I'm tired, I want to go to bed now, are we there yet? Like, those are the fun. I just made that up. I like that. But so that's all the BMS. We talk to the BMS and it says, I'm hungry. All right, here you go. Are we there yet? No, here's a bit more.
Yeah, cut the analogy about I want to go to sleep would be confusing. Well, you're in the middle of a bus run. Shut up and get on with it.
Work. Yeah, I don't know. Perfect. But yeah, I mean, the astute of you to see that. Rivian knows where it's going, and so does Amazon. And at some point, they have parallel paths and convergent paths. And that future is the one that we'll be into. So it's just an exciting time to be part of it.
The way I could imagine it developing in the next sort of 10 years or so is that it becomes a very common sight or a common thing that, commercial vehicles use induction charging, and they go, and then you'll eventually see a UPS delivery van and you go, well, where'd you plug it in? And the driver goes, I don't know. You can't. You don't need it, but after that, then I can imagine private vehicles or, just ordinary cars starting to use it, because there's so much of that infrastructure. It's really down to the infrastructure, isn't it? If there is a lot of pads knocking around in car parks and on by the side of the street, you can imagine then you get your new, Renault Zoe 500.
If you want to make my boss turn purple, you show him an electric vehicle sign that has a plug on it.
Yeah.
That's not the solution. That's not the benefit. It's the application. It's like showing a microwave by showing its plug. That's not what the microwave does. So we are honestly, literally lobbying this Department of Transport to have a more generic means of showing charging that doesn't limit you to having a bloody great cable sticking out the back of your car.
Well, it's also that the thing. If the amount of photographs of me taken by the press, where I'm standing by a Nissan Leaf, a Renault Zoe, a BMW i3, a Tesla, holding the wire. Can you hold the wire? They go, well, you don't hold the wire. Well, just hold the wire. It looks good. No, it doesn't. It looks stupid. No, hold the wire. I now flatly refuse to hold the damn wire, but because that's, people understand that's what you do with a fuel pump, a petrol pump.
Well, in the great state of New Jersey where I live, you do not pump your own gas. The attendants pump it for you. You're not allowed to pump it. So that'll be an interesting, if there are public charging points, do we have to have a little man or a little woman standing next to the pump saying, no, I'll do that.
And is that actually like a bylaw or a law? You literally cannot do it yourself.
Right, in the state of New Jersey, in a couple of other states, most you can, but here, and it's also why you cannot put in certain states in the US fuel stations on the side of the highway. So if you drive the great roads of America, you won't see fuel stations. They're off the road on a clover leaf and then half a mile away. And that was done at the time to protect local businesses, because they didn't want these great highways coming through and robbing them of their business. But now it means that a lot of states cannot put charging on the side of the road, on the interstates. Same regulations. So there's a lot of little dings and nicks we have to take out of this system.
No, there's a lot of legacy thought in a way, and because it is a very different beast. I've just thought of a question. Here's an important question. When you've got a wire, because I've got one of these in my house now, when you've got a wire, you can plug it in the car and plug it in the wall, and the electricity can go both ways. So you might never want to do this, but could you use induction charging as a vehicle to grid system? Would it go the other way?
I'm not in the office now, but I can hear them running towards me now saying, stop talking. But... But in all theory and most practice, you can do that because it's just a matter of reversing the process. So, and because the pads are identical, the pad on the vehicle and the pad on the ground are the same thing. But in terms of vehicle to grid, it's just a reversing of that you need an acceptance, beyond the pad. But yes, the pad will take energy back in just as much as it pushes it out, as long as you have the right acceptance beyond that.
That is very interesting. I mean, because I think there is, there's an aspect, particularly with commercial vehicles, particularly with large fleets of vehicles, and this is from talking to the national grid operators here, that there is a potential there. And what you're talking about is you're not, because people sort of think you're just draining the whole battery down when you're pumping electricity into the grid. It's having 5, 10, 15 million vehicles, and you take 1 kilowatt hour each. Well, that's 2 miles in a bus, 5 miles in a car, maybe. So you're not taking a lot out of them. But if you can do that at critical times in the day, depending on demand, that's multiple nuclear power stations worth of power, and that's, I think, I think there are clear advantages to having that ability, to using that power, that stored power, when you don't need it for anything else.
It's the automotive equivalent of Bitcoin mining. So what you'll do is you'll charge your vehicle overnight and then wait for the highest bidder during the day and then sell a bit back. Yeah.
That is brilliant, Mike. I mean, that's been such a fascinating insight into that, and I mean, I'm really excited. So the test scheme in Oslo is going live. How soon is that actually happening, or will there be eye-paced taxis zooming around.
The gateway for the announcement that we've just made was the testing of the vehicle at Jaguar. So Jaguar took the vehicle, integrated our technology into it, made sure it worked. Everybody's happy, thumbs up. So that's why we can talk about it now. The original plan to have them working was September time, and September in Oslo is lovely, and I was looking forward to that. But it now, with everything that's moved on, it might be end of year. So, but when that happens, we would love to have you along, and part of that, talk to a driver. I just want to get those Norwegian drivers, explaining their lives and how this changes them. It's I think it's a fascinating real world application.
I'm very excited about that. So yeah, I'm very much looking forward to seeing that. And it's the other. I just pray that you get some traction with delivery companies and bus companies to install it, because it makes so much sense. And there's this. You may not be aware of it, but there's a bit of a hoo-ha at the moment, a planning application, and it's already gone through, a big Ocado delivery hub in northeast London, which is fine. It's going to employ lots of people, and loads of people get their deliveries done. But the driveway up to it, the roadway up to the delivery bays where the vans load up, is right next to a primary school playground with children. And there's going to be hundreds every day. And according to Ocado, possibly thousands of diesel vans in a queue with their engines ticking over next to a kid's playground. You just go, this is just wrong that we're doing this now. Why isn't Ocado making that leap? And the technology you're talking about would be a positive benefit. That roadway, for a start, could have pads all the way along it, so as they're waiting and moving forward, they can charge, and then when they're loading, they can charge. It's the perfect place, isn't it?
This is really, really fascinating, isn't it? We've been around this industry a long time, and we're moving at such speed and pace that the plugging chargers are already the legacy manufacturers. So we say the legacy people won't get out of our way and they're slowing everything down. The plug-in people we're the next generation coming through, trying to re-educate people. You don't have to plug it in. You don't have to do it the old way. Like the old way. We've only just started doing this. It's the old way. But we don't have to do it that way. There are better ways. And of course, there are people who are invested in keeping the old way because that's their way and it's the way that is. So it's just a re-education process,
No, it's really good. Thank you so much, Michael. It's been really good. And I know that, there's going to be a lot of interest in this from our many listeners. But that's brilliant. Thanks so much for your time today. Well, I really hope you enjoyed that. It was absolutely fascinating. I learned an enormous amount talking to Michael. Really, really exciting development. Can't wait for, I want to be cycling down a street in London and see that they're digging it up. And why they're digging it up? Because they're putting in induction charging plates all down the side of the street where people park their electric cars. And they just park them there and they start charging and you don't do anything. What a brilliant system. I think it will develop over the next few years. I think we're going to see more and more of it. Anyway, that's all for this week. Because of the extraordinary professionalism with which the Fully Charged Show podcast is produced, we actually know what next week's episode is. It's an interview with the wonderful Fiona Howarth. She's actually been on the show before, but there's been so many exciting things happening in her field of business. Fiona runs the electric vehicles section at Octopus Energy in the UK. Now, Octopus Energy are, I think it's fair to say, a pretty remarkable energy company. And they've been in the news a lot recently because due to the enormous amount of renewable energy we've had during lockdown, when demand has been lower, we have had numerous periods of time when the wholesale energy price goes negative. And if you're an Octopus Agile customer, so does your electricity supply. There are now numerous cases where people have added hundreds of miles to their electric cars, charging them during these periods of negative pricing, where they have been paid actual money to charge their cars. Fiona Howarth will explain in next week's episode, so don't miss it. And the best way not to miss it, of course, is to subscribe on whatever podcast app you use. Subscribe to the Fully Charged Show podcast. Absolutely marvellous. And also, if you found this podcast and don't know about the show on YouTube, which now has 670,000 subscribers and 3 million views a month. Fully Charged Show has been going for 10 years, hobbling and stumbling along for 10 years, and we'd love you to watch that show too. That's all. As always, if you have been, thank you for listening.